now let's look at this deceptively simple geometric problem. Right, looks like a very simple problem. It's a rectangle. It's a right angle triangle. Right, so this angle is 90 degrees. Right, the whole thing is a triangle, and then we are given the length of this side, which is 3, and then this side is 7. Right, and then we need to evaluate the area of this rectangle. Right. So how do we solve it? Right, it looks like a very simple problem, but in fact it's not really that simple. It's the reason is that the given information, the 3 and 7, this length and this length, are not really related to this rectangle in any direct way. If you want to evaluate the area of the rectangle, you have to know the length of the two sides, right? But the length of the two sides are not given directly, right? 7 cannot be related to this side or this side directly. 3 cannot be related to this side or this side directly. So how we are going to solve this problem? We're going to use two different methods. One is kind of a more geometrical, the other one is a more algebraic, right? So let's look at the geometrical way. So how we're going to solve it, right? So solution 1, which is the geometrical way. So what we are going to do is that we're going to try to make up a rectangle using half of the triangle, right? So what we can do is to actually just shift this line upwards and then shift this vertical line to the right, right? So now we can make up a right angle triangle that's kind of exactly identical to this right angle triangle, except that it's being kind of flipped, right? And then we can extend this line, this vertical line, upwards, and then extend this horizontal line to the right, right? So we know that this side is 3, right? And this side is also going to be 3. So we know this side, right? This side is 7, so we also know this side is 7, right? Because the whole thing is a rectangle, right? So we know this area. This area is what? Is 3 times 7 equals 21, right? So what do we know about this rectangle, right? We know that this triangle is half of the area of the whole rectangle, right? So this triangle, the triangle that we made up, should also be half of the area of the big rectangle, right? So the area of these two big triangles should be equal to each other, right? And then let's look at this small triangle, right? This small triangle and this small triangle, the area of these two small triangles should be the same too, right? And then let's look at this rectangle, right? This rectangle, and then this triangle should have the same area as this triangle, right? So the whole triangle, the big triangle, should have the same area as this big triangle, right? And then these two small triangles also have the same area, right? This triangle and this triangle should have the same area, right? So that means what? That means this rectangle should have the same area as this rectangle, right? And this rectangle has an area of 21, so this area should be also 10. The area of this rectangle should also be 21, and 21 is indeed our answer, right? That's this solution, the geometric solution. Now let's look at the second solution, right, which is more algebraic. So what are we gonna do? We don't really know the length of these two sides, so let's introduce some variables. We're gonna call the horizontal length x, and then the vertical length y, right? So all we have to do is to try to evaluate what's going to be x times y. What's this value, right? So what do we know? What do we know, right? So if this is x, then this is x2, right? And then if this is y, then this is y2, right? So now we can look at some relations, right? So if we look at this right angle triangle, we know that this square plus this square equals to the length of this side squared, right? If we look at this right angle triangle, we know that this square plus 7 squared should equal to the length of this side squared, right? So that's 3 squared, that's 9, plus x squared, right? That should equal to the square of this length, right? So if we take the square root, we should get this length, right? And then let's evaluate this length. It's going to be y squared plus 49, right? That's the square of this length. Take the square root of it, then we get this length, right? And then we add them together. That should be the total length, right? The total length of this side, right? And then now let's look at this big right angle triangle, right? This side is 3 plus y, right? 3 plus y. 3 plus y. If we square it, right, that's 3 plus y squared. And then this side is 7 plus x, right? 7 plus x, right? And then if we square it also, that gives us the square of this side, right? And this side, the square of this side plus the square of this side should equal to the square of this side, right? If we add them together, it should be equal to the square of this side, right? We know the length of this side is this expression, right? So all we have to do is to square it, right? And then these two should equal to each other, right? So now we can expand it. It's not really that difficult to actually do those kind of evaluations. So it's going to be x squared plus 9, that's this squared, plus y squared plus 49, right? And then plus 2 times the square of 9 plus x squared times 49 plus y squared, right? Expand this side, and then the right hand side is going to be 9 plus y squared plus 6y plus 49 plus x squared plus 14x, right? And at this point we can do some cancellation, right? And then this 2 can be cancelled out also with the, so now it's a 3, and then now it's a 7, right? So it's a 3y plus 7x. 3y plus 7x is going to equal to, that's the right hand side. What's going to be, it's going to equal to the square root of the whole thing, right? It's going to equal to the square root of 9 plus x squared 49 plus y squared, right? And then we can square both sides again, right? We can square both sides again. That's going to give you 9y squared plus 49x squared plus 42x times y equals to the whole thing squared, right? It's going to be 9 plus x squared times 49 plus y squared, right? And then we can expand the right hand side. It's going to be 49 times 9, 49 times 9 plus x squared times y squared plus 9y squared plus 49x squared, right? And at this point we can do some cancellation again. 49x squared cancel out, right? And then 9y squared and 9y squared cancel out, right? We end up with what? Xy squared, x times y squared, 42x times y, and then 49 times 9, right? So we know that x times y is actually the area, right? The area of this rectangle. So let's just denote x times y equals to a, right? A is the value that we are going after. So now we know that, so this is a squared, right? This is a squared plus, no, subtract 42. X times y, that's 42a. Right? And then plus 49 times 9 equals to 0. And this is a second order polynomial with respect to a, the value that we are going after. So how we are going to solve it, right? So a, we can use the formula a equals to 42 plus or minus square root of 42 squared subtract 4 times 49 times 9. Right? So it's gonna equal to cancel out 21 plus minus, it divided 2 into the square root, that's gonna be 21 squared subtract 49 times 9, right? And 49 is what? 49 is 7 squared, right? 7 times 7. 9 is what? 9 is 3 squared, right? So it's 7 squared times 3 squared. So it equals to 7 times 3. The whole thing squared, right? 7 times 3, that's 21. 21 squared subtract 21 squared, that's exactly 0. So this term is actually 0. So now we get a equals to 21, right? So that's exactly the same as the value that we got from the geometrical method.